Hello everyone. I also first of all would like to thank 2014 Wood Culture Symposium organizers for the kind invitations. Let me wear my glasses, I cannot see quite well. Okay, so I would like to talk about wood science for culturally important artifacts, which is a big title, but what under this title, what I would like to talk about is the important artifact has to be investigated by non-destructive methods. There are not a lot of methods to do for wood identifications. Here, how to identify wood species without making preparation for optical microscopy. If you can cut optical microscopy, you can send everything to Peter Voss or Professor Ito, and the solution is there. But it is not always the case. There are many statues and important artifacts which we cannot do that sort of things. For that purposes, for that sense, we are recently investigating the non-destructive analysis method to identify wood. One is spectroscopy and the other is X-ray computed tomography. The first, I would like to start the spectroscopy method. We use near-infrared spectroscopy, and near-infrared here is located in between ultraviolet and infrared regions. And radiation in this domain is insensitive to water, so the water content substances such as wood is rather good for these methods. Particularly how we apply is that this is Akamatsu Pinus densiflora on your left-hand side. On the right-hand side is Pinus thunbergi. We call Akamatsu and Kuromatsu, red pine and black pines. And those are, from the tree features, quite different and very easily distinguishable. But if you look at the anatomical structures, it is very quite similar. Only the professionalist can identify using dentate thickness here of the ray tractate, but it is not always true. Sometimes even thunbergi has a very strong dentate thickness. Even such optically, microscopically difficult species using infrared spectroscopy together with statistical analysis, what we call partial least square discriminant analysis, which is one of the multivariate spectral analysis, we are able to separate thunbergi and densiflora quite easily and reproducibly. So this type of technique is quite easy, and recently near-infrared machine became very small and handy. It can be portable. So with this machine you can go to the on-site measurement for the articles. So this is the future of this method. But very recently we found that this method is influenced by the chemical modifications of the sample. So it is still difficult to apply directly to the old wood, for instance, excavated wood, because the chemical composition is slightly degraded from the present wood. But there is a way to improve it. And the next topic is X-ray computed tomography. There are two types of samples which I am going to talk about. One is the very small, tiny samples of national treasure class Buddha statue, for instance. Very small, easy, uneasy to handle, so you cannot cut sections. In that case, we use high-resolution computer tomography. And the next one is the object is so big, like the Buddha statue over there, and even more like my size. Then the image information becomes very low resolutions. Still, we want to identify it. Is there any way to identify? This is the target of the study. So first I start from the high resolution part. Here we are. This is the statue standing on your right hand side. Is a masterpiece Buddha statue constructed in the 13th century, Kamakura, made by the Unkei group, famous carpenters group. And according to the literature, this statue was made either Sericivifram japonicum, which is Katsura, or Magnolia. But there was no scientific evidence about it. So when this statue was restored, the curators collected very small sample when accidentally fallen from the statue. And this is the sample here. The length is about about 4 millimeter, and the thickness is about 0.7 millimeters wide. But even from such small fragments, and furthermore, it was very compressed. By using very strong X-ray lights, which we use, the one we use is the synchronous X-ray radiations at Harima, we get this type of images. Surprisingly, if you select the proper conditions, the resolution of image is as good as 0.5 micrometers. That means you can see most of all the anatomical characters which are necessary to identify, according to the book written by Peter Burrs and others. So then it is easy to do that. In this case, because of the scholarly form and unizariate lay, but in the middle you have bizariate lay. This is a typical characteristic of sericivity 1. So we decided that this is Katsura. So this is one example when the sample is very small, and then if you think that sample will be never obtained, this is the way to do that. So the second, which is my main talk of today, is the low resolution type images. This is collaboration work with the team of Dr. Imazu, with curators of Kyushu National Museum. The National Museum, as you know, that is the only place where the cultural treasure class wood materials goes and through. So it is the chance for us to get the information as much as possible. And in this particular museum, they have a large-scale X-ray machines. If you compare with the lady standing over there, with 165 meter tall, so that means the huge human body type Buddha can be CT'd. The typical images that we can obtain from those machines is like that. And then normally they analyze what is the joint position structures and what kind of nail has been used, where it is located, this type of information they want to get. This is the, how do you say, general reasoning for them doing. However, for us, if we look at these pictures, wood scientists think that it might be possible to identify wood. Because on the shoulder part and the body part, there is completely different textures of annual rings formations. So we thought it might be possible by introducing image recognition technology recently available even in the simple camera, for instance, face recognitions algorithms. By making use of those new technology, we try to find a way to help understanding identifications. So this is my algorithm at the moment. Input is CT images. From the CT images, with the three-dimensional digital data set, I prepare cross-sections and radial sections and tangential sections. And the next procedure is extract image informations. In this case, I am going to talk about the Gray level co-occurrence matrix. And with those informations, we prepared also the database from wood frequently used for carving, and compare the informations with the target images, and then extract the answer by KNN recognition procedure to give the answers. So I'm not going to detail in this process, but I would like to talk about a little bit more about Gray level co-occurrence matrix that I'm using and these samples. Samples that have been investigated is the samples that have been used frequently in the wooden statues and the wooden artifacts. From the top, for instance, Cryptomeria japonica, Kamae spice obtusa, Hinoki, Magnolia, Cerisdiphyllum, Torreya, Cercova, Paulownia, and Cinnamonum, and Cryptomeria japonica, and so on. So from those images, we collected the image information. How we extracted the image information is the Gray level co-occurrence matrix. So this is a little bit complicated, so I'm going slowly. So now I have an image here. On your left top, yes. There is 1, 2, 3, 4, 5, and 5 by pixels. So this image is 5 by 5 pixel images. And the Gray level is, this is 0 and 1 and 2 and 3. So there are 4 levels of image, grayscale intensity. So suppose we start from these images. And here is the same representations of this image, but the Gray level is represented by the numbers. So we set up first rectangle here, and the first column is I, and the second column is J. And what we do is to see the Gray level of I and J positions, and then moving this rectangle to these directions one by one, and then correct the information. For instance, in this case, I equals 0 and J equals 1. So I equals 0 and J equals 1. So you count 1 here. And if you move it here, 1, 1, so that you get I equals 1 and J equals 1. So you put 1 here. Like this, you go straight all the way to the end. And then when you reach to the end, you come back. You come back. And then you get this matrix. You plus those two matrices, and then you end up with these ones. So this is what we call the grayscale or gray level or co-occurrence matrix. And this matrix was obtained after the 40 times translations of the image processing. So divided by 40, and it becomes percentage, probability. Okay. So, and then from this probability function, Pij, we are going to calculate many informations. One of them is angular second moment, which is represented by square of sum, just the square of sum. So in these images, for these images, typically it is calculated to 0.1175. Without knowing what it is, I can calculate this type of things. So, but suppose if there is images, monotone images with the grayscale level 2, what happens? 2 and 2 or 40 times, so the probability is 1, and you get sum of the probability equal 1. So this one. So that means this ASMM information is if the contrast is fluctuating, you get less than 1 values, and if it's close to the monotone, you get value close to 1. Like these. There are many functions that has been used for the image recognition processes. In our case, I used 12 informations. Okay? So far, what I have been studied is the relationship between successful correct identifications. Here is a table. I am concerned about the 3 centimeter and 3 centimeter size of the images. If I can get the 3 centimeter images with resolutions of 0.1 millimeter with gray level 256 values. This is maximum resolutions, best resolutions. In this case, the gray level is 256 still, but the resolution is 0.1. But if it reduced to the resolution 1, the image becomes like that. It's miserable things. So, by the way, this is the picture of Cercova serrata. However, so far we found that if the resolution is better than 0.4 millimeter and gray level is more than 16, the recognition is 100% possible. So now, this study is just started, and then we are on the way to construct stable models and stable, how do you say that, recognition procedure algorithms, and so on. But probably within 2 years, we are able to apply this technique to investigate registered wooden artifacts and lacquerware, which are not be able to see from the outside, or no masks, which are culturally important. Thank you very much for kind attention.